Hello everyone, myself Sowmya, Assistant Professor in CSE AIML Department, MLR Institute of Technology. In this video, we are going to discuss about security in blockchain. So we know blockchain we are using for security purpose only, but still it also lacking of security in some aspects. So we'll see what are those aspects and how we are overcoming those aspects using blockchain. So coming to the overview of this presentation covers security aspects in Bitcoin, security and privacy challenges in blockchain in general, performance and scalability, identity management and authentication, regularity, compliance and assurance, safeguarding blockchain smart contracts, security aspects in Hyperledger Fabric. So how security, we can provide the security using blockchain in different aspects we will see in this video. So security aspects in Bitcoin. So we know Bitcoin is the first ever cryptocurrency which uses blockchain technology. So Bitcoin relies on cryptographic techniques, particularly public and private keys, to ensure the secure transaction. So as we know, Bitcoin is a cryptocurrency. How we are providing the security for this Bitcoin cryptocurrency in the sense using the public and private keys. So we know we are maintaining these Bitcoins in the form of wallets, right? So digital wallet, we are maintaining this cryptocurrency. So if I want to send some funds to other account, then I should know my private key. The same way, if I want to log into my account to receive the funds, or else if some other person wants to send the funds to my account, then they should know the public key. So using this public and private key, we can secure our digital wallet or Bitcoin. So it uses proof of work for mining, making it resistant for tampering. So we know proof of work is very complex consensus algorithm. So using this, we are going to authenticate or validate the transaction, whether the transaction is valid or not. So that we can check or that we can validate using proof of work. So which is a very complex algorithm. So it's not very easy to tamper it. But it is still vulnerable to 51% attacks, where a single entity gains majority control over the network's mining power. Here, majority of the voting, I'm proposing a block of transaction. So how I can say whether this transaction is valid or not? So based on the number of votings. So if 51%, for example, we have 100 nodes. If the 51 nodes are handled by a single authority, so which is not a trusted one, then obviously they'll go with a wrong judgment, right? So the 49 are valid users, but even though if they go with the proper voting, we cannot consider that. Why? Because 51 is a majority, right? So that is called 51% attack. If the majority of the persons or a majority of the nodes are handled by a single authority, which may not be a trusted one, then it may lead to 51% attack. So ensures anonymity of users but has faced issues with the security breaches in exchanges and wallet providers. So we know like the users are anonymous here as we don't know the public or private keys of any of the persons, right? Public key or private key, it is very lengthy, right? So here we are using 256 bits or 128 bits address for public key or private key address. So using that, we can't even identify the person name. For example, in GPay, if I enter a phone number, immediately I'll see the identity of the person. That means it will show the account name of the person. But it's not like in this cryptocurrency. Whenever you enter a public address or private address, it will not show the user details. So what is the username? What is the, where the user belongs to? What is the IP of the user? All these things we can't estimate. Though it is very anonymous. The users are anonymous here. But still, we are facing some issues with the security breaches. As we are using digital wallet here, digital cryptocurrency, there is a chance to get the security breaches. Of course, we have some case studies also where the security breaches have been occurred. So security and privacy challenges in general. So generally in blockchain, what are the security issues we are facing and how we are overcoming that? So blockchain provides transparency. We know it is very transparent. Whatever the transactions are there in the blockchain, everyone can see. Of course, they can't modify it, but still they can see the transactions. But this can be privacy issue. This can lead to privacy issue, especially for sensitive transactions. So if the transactions are open, or if the transactions are transparent, everyone can see the transaction, what's happening in the transaction, how much funds are transferring from one account to other account. So everything we can see here. If that information is containing any sensitive information, that will be leaked. There's a chance to leak that privacy information also. Of course, the user cannot modify that information, but he can get that information. So risk include data immutability, which makes it difficult to delete enormous or sensitive information. So here blockchain ledgers are immutable. Once if I have written the content onto the blockchain ledger, we can't modify it, we can't edit that. So that's the problem here. If I have written any erroneous information into the blockchain, so later if I want to modify that, I can't do that. That's a problem with the blockchain because of this immutability feature. So vulnerable to endpoint security threats such as malware targeting wallets or application interacting with the blockchain. So as we are discussing with the cryptocurrency, digital currency, there is a chance to get the malware targeting attacks. So malware attacks are possible against this digital wallets. So how to preserve this privacy? So for the privacy preserving, we are using some of the techniques in general in the blockchain. So those are ZK snacks. So that is nothing but zero knowledge second non-interactive argument of knowledge. So simply you can call it as zero knowledge proofs. And ring signatures, secure multi-party communication. So we will see what are these techniques in the next slides. So first one is ZK snacks. So zero knowledge. I want to convey, a person A wants to convey some information to person B. So it is containing some sensitive information or it is containing some privacy information. Then what A needs to do, he needs to just communicate that information without revealing any secrecy, any secret information. For example, I'm telling, the person A is telling that A got some 100 bitcoins. He got some 100 bitcoins. So he is conveying this information to B. But he is not revealing how he got that 100 coins. What is the process? I mean, by which process he got that? That internal information he is not revealing. He needs to convey only the information to B, but without revealing any internal information, any secrecy information. Right? So that is nothing but zero knowledge. Zero knowledge is nothing but a cryptographic method allowing one party to prove another party that a statement is true without revealing any additional information apart from the fact that the statement is true. So what is A wants to convey? That he got $100 or 100 bitcoins in his account. So how he is getting all those things, he is not going to reveal, but he has to prove that he got that 100 bitcoins in his wallet. So that is nothing but zero knowledge. So by this, I mean, with this technology, how we can use in blockchain, how we can preserve the privacy, we'll see. So ZK snacks are used in privacy focused blockchains like Zcash. So Zcash is one of the cryptocurrency which uses again this blockchain only to hide transaction details such as the sender, receiver, amount, while still allowing validators to confirm the validity of the transaction. So in Zcash, we are using the zero knowledge proof, so that the validator can validate the transaction without knowing the sender details or receiver details or the amount what the sender is sending. So this enhances the privacy without compromising the security and integrity. So here the validator is going to validate the transaction, but still he is not going to get any internal information or any private information here. So that is nothing but zero knowledge proof. Using the zero knowledge proof, we can preserve the privacy in general in blockchain. So next is ring signature. So ring signature is another mechanism where we can preserve the privacy. So in ring signature, we have a group of people. So in group of people, randomly one member will come and he will sign. And that sign they're going to consider as a group signature. So now later, for example, I'm asking out of 60 students, I'm asking one person to sign. Sign means it's a digital signature here. I'm asking one person to sign, and I'm mixing that signature among the 60 signatures. Then I can't, and I'm telling that single signature is going to work as a group signature. So that single signature will be given as a group signature. Now if I mix that signature in a group of 60, I can't identify which one is the previous signature, something like that. So that you can provide the security here. So that's the concept of ring signature. So in ring signature, one person among the multiple members will sign, will give the digital signature, and that digital signature you're going to consider as a group signature. So ring signature are the key component of privacy focused cryptocurrencies like Monero. So Monero is also one of the cryptocurrency where it is using the ring signature concept. So they help obscure the identity of transaction sender by mixing their signature with those of other users in the network, ensuring the anonymity. So here the sender is going to sign and that signature is going to mix along with other users in the network so that the user signature will be anonymous. So next is secure multi-party computation, so SMPC. So it is a cryptographic protocol that enables multiple parties to jointly compute a function over their inputs while keeping those inputs private from each other. So here 4 persons are there. The 4 persons need to calculate one function. So this function is going to use all the inputs which are provided by these persons. So if I know ABCD values, if I have ABCD values, then only I can calculate this function. So these 4 persons, they are using ABCD values to calculate this function. So this function value will be known to each other. This f of x value will be, the final value will be known to each other, but the A value, whichever it belonging to this particular user, is not revealed to other user. So even though they are using their inputs internally to calculate the function, but they are not sharing that input value with others. So here we are providing the security, privacy for your information, as well as the function calculation is also happening. So next is performance and scalability. So performance and scalability, how the blockchain, how the performance will be in blockchain and how it is scalable to which applications. What is the problem with the scalability in blockchain? We will see that it also comes under security. So scalability is a major issue due to the time and resource consumption of consensus mechanism like POW. So we know proof of work is one of the main consensus algorithm which is followed by the Bitcoin. Of course, generally in blockchain also we are using this proof of work mechanism. But for this proof of work, it needs a lot of complexity, lot of power to calculate, to perform that consensus process. So because of this, scalability will become the major issue. So whatever the complex things or whatever the data, we need to maintain at each and every node so that I can't accommodate the space which I have. So for this, what is a solution? Solutions such as sharding and next to proof of stake can be used. So instead of proof of work, we can also use proof of stake, or we can also use sharding technique. Sharding means it's a database partitioning technique where the blockchain's data is divided into smaller pieces called shards. So here, instead of maintaining the bulk data together, we are dividing the data into chunks, and each chunk you're calling as a shard. So that whenever you need a particular data, then all these chunks will be added together to get the final information. So you're not storing the information together at some place, at one place. So this will be divided into chunks and distributed to multiple blocks. And next, another thing is proof of stake. So in proof of stake, the complexity will be reduced when compared to the proof of work. So in proof of stake, the user who is going to validate the transaction needs to stake some amount as a collateral. So if I stake some amount, then only I am eligible to validate the transaction. So these are the two things which are using in the blockchain in real world also. Ethereum is implementing sharding as part of its scalability upgrade to Ethereum 2.0. So in Ethereum 2.0, they were using the sharding technique. And Ethereum transitioned to POS with the merge in 2022. So previously Ethereum was using POW only, proof of work only, but in 2022 the version merged. So it is using proof of stake. So reducing the energy consumption and paving the way for the future scalability upgrades. So using this POS, proof of stake, we can reduce the scalability issues. So high transaction fees and latency during peak usage can limit the widespread adoption of blockchain. So if we have multiple drawbacks with the blockchain, then the people will not prefer to use this blockchain. So next, identity management and authentication. So generally, how I can validate a user? How can how can I provide the identity details for a user? So as we know, blockchain is very secure for providing the identity information. So if I want to use any cryptocurrency, I need to know my public and private keys, which are very lengthy, which I cannot share with other persons. Even the person or the hacker cannot hack that information easily. So blockchain provides decentralized identity management solution, eliminating reliance on the central authorities. So here, if I want to log in, I can give the public key or private key directly. There will be no central authority to validate this transaction. Whether these details are valid or not, to check that, there will be no central authority here. But in blockchain, if it is a centralized, we need to follow that process. But blockchain is a decentralized process. If you have given the details, automatically it will be verified. There will be no central authority here. If it is really valid, then you can go further. So digital identities can be managed with self-sovereign identity. Self-sovereign identity standards in the sense the user itself can maintain the public and private keys. So we are not going to store this public and private keys anywhere in the server. If I consider our college website, the students are having passwords and their roll numbers and passwords. All these things will be stored in our college server, right? But here in this digital identity management, we don't need to store our public or private keys anywhere in the server. Right, so the user can have he has his own handling of that information, so he can modify that data whenever he wants. So public key infrastructure is used for authentication. So public key infrastructure is nothing but where we are using the public key as well as private key. So blockchain based identity management can prevent fraud and streamline verification process. So we can prevent the fraud as it is a very lengthy key. No one can hack that. No one can get the information easily, and streamline the verification process. So generally, if I want to log into Gmail account or any other account, we have a lengthy process. Lengthy process in the sense, in the server, we have already existing details. Our details will be compared with the server details. If it is matched, then only I am able to log in into my account. But here, the verification process will be very simple in blockchain. So regulatory compliance and assurance. So generally, if I want to use blockchain in our college, we need to follow some standards. So our college is having some policies. So according to that, the blockchain network has to follow. So like that, in our India, if I want to implement, we have some regulatory issues, right? We have some rules and regulations. So whether this blockchain network is following that or not, I need to check all these things. So blockchain is still emerging in regulatory frameworks, creating challenges and for compliance with the legal standards. So legally, if I want to use blockchain, it has to follow so many rules and regulations. So that is still in the process. So compliance standard like AIML, anti-money laundering, or KYC, know your customer process. So these two we can't do easily using this decentralized network. So anti-money laundering is nothing but set of laws, regulations, procedures designed to prevent the generation of income through illegal activities such as fraud, drug trafficking, terrorism financing, or corruption. So know your customer. So it is a process to regularize our business, right? So whether our account is valid or not, all these things. So to follow this AML or KYC process, it's not very simple using this decentralized networks. So to overcome this issue, you are using smart contracts, introduce new legal challenges as code-based agreements may lack human oversight and adaptability. So this is one more issue. So a smart contract already we discussed in the previous videos. So it is an auto executable code. So whenever a certain condition is true, automatically the action will happen, right? So if the code is not correctly written, so it may lead to some illegal issues, right? So already we have some cases like DAO attacked in 2010 just because of 2017 just because of the smart contract issue. So if you don't write the code in a proper way, so that may lead to multiple issues. So governments are still working on regulatory frameworks for blockchain to ensure security, privacy, and transparency in operations. So still it is in the process. If the government regulations are followed by blockchain network, then legally we can use this in any way. So safeguarding blockchain smart contracts. So how we can, because of the smart contract is an auto executable code, right? So whenever a particular condition is true, automatically the action will happen. So if I don't write the smart contract properly, if I don't verify the smart contract properly, it may lead to multiple issues. So how can we safeguard this smart contract? So smart contracts are self-executing programs which, if not coded securely, can be vulnerable to attacks. So the common attacks are re-entry attacks, overflow errors, logical flaws. So re-entry attacks in the sense a function, like for example, I'm doing an action. So without completing that, again it is doing the same task again. For example, I have some 50 bitcoins in my account. I want to send all these 50 bitcoins to some other account B. So this still this transaction is happening. Again, the same function will be called. The same 50 bitcoins will be transferred to some other account or used for some other purpose, something like double spending, right? It may happen if the code is not correctly written. So tools like formal verification and rigorous auditing are used for safeguarding the smart contracts. So a formal verification, properly we need to verify the smart contract before deploying onto the blockchain. So security focused programming languages like Solidity and Viper for Ethereum can help minimize the risk in smart contract code. So generally to write the smart contract, we are using some programming languages like Solidity or Viper. Using that, we can somewhat reduce the risk of this attacks. So next is security aspects in Hyperledger Fabric. So Hyperledger Fabric offers a permissioned blockchain environment. So Hyperledger Fabric is not a public blockchain. It is a permissioned blockchain, just like a private blockchain. So with enhanced control over the data access and transaction privacy. So when it comes to the permission blockchain, it almost similar to the centralized. Permissioned in the sense like a set of people will be organized, a set of people will be monitored that network, right? So features identity management and access control, allowing only authorized users to participate in the transaction. So here it's not open to all, only the authorized users can access that. So uses private data collection to restrict data visibility, meeting regulatory requirements for privacy. So here the data is not visible to all. So we have some privacy information, so that will be visible only to the authorized people. So endorsement policies must endorse a transaction proposal before it can be considered valid. In Fabric provide flexibility in determining who can validate the transaction, improving the security. So if it is a public blockchain, anyone can validate, anyone can initiate the transaction, but Hyperledger Fabric is a permission blockchain. We have some set of people here. They can only initiate the transaction, they can only validate the transaction. The only thing, the users can only see the transaction, but they don't have any right to modify or any right to propose the transaction. So that is about the security aspects in blockchain. So in this video, we discussed the different security aspects in Bitcoin, security aspects in general blockchain, and performance and scalability, identity management, regularity assurance, safeguarding the blockchain smart contract, and security aspects in the Hyperledger Fabric, which is a permission blockchain.